I'm going through the Wits University Math Competition 2019 first round questions, and this is the paper for grade 10 to grade 12. As with the other ones, I'm not going to repeat questions that are in previous papers for the other years, so I've already filled in those answers, and question 6, question 9 and question 12 are unique to this grade 10 to grade 12 paper. So let's start at question 6. How many rectangles are there in the following picture? Include rectangles of all sizes. Okay, so this is the picture. Okay, obviously it's quite a small square, so it's easy enough to just count them. If we start at this point, we want to count all of the rectangles that can be done. So obviously, let's just basically say, well, count top left and bottom right corner. So we've got a square, I suppose is technically a rectangle. Let me just check. A square is considered also a rectangle. So from this corner, you can go from there. So it's 1, 2. That's going to be this rectangle. 3. Is that rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9. So from the top left corner, I'm just going to write it in here. We've got 9 possible rectangles. Let's say we move across to here. So if this is the top left corner, obviously now we've only got 6. We can't count these ones because we've already said that that's the top left corner. So it's from there to there, from there to there, from there to there, from there to there, from there to there. So as before, here we have got 6 possibilities. Over here we've got only 3 possibilities, so it's either this square, that rectangle, or that rectangle. So that's 3. By symmetry, we're going to get the same here. There's a 6 and there's a 3. From this corner, if this is the top left, there are 4 options. If this is the top left, here we've got 2 options, and there we've also got 2 options, and then here is only 1. Obviously, that is that square. So let's quickly add all of this up. I'm just going to say 9 plus 1, 6 plus 4, so let's scratch them out as we go. 6 and 4 is 10, 6 and 2 and 2. And lastly, we've got 3 plus 3. Okay, so that's 10, 10, 10, 6. So the answer is 36. Let's see, so that is C. Just for out of curiosity, so obviously this was a small grid, so it makes it much easier to count. But if we had a massive grid, let us say that this was, I don't know, 70 by 50. Obviously something like this, if you want a general formula, what you want to do is a rectangle can be defined based on, so let's draw all of these lines. Okay, so let us say that we wanted to solve this this question. a rectangle can be defined as the region bound by two vertical lines. So let's say we're going to put a vertical line there and a vertical line there, and two horizontal lines, hypothetically one there and one there. Okay, obviously I haven't drawn a full grid, but let's say that this was a 70 by 50. How many places are there to pick these two lines? Well, if it's a 70 by 70 grid, the first option, so we want to draw one vertical line, there are 71 places we can put that. So 71. The second vertical line has got, obviously you can't put the same line twice. A rectangle, you're not defining a rectangle if you've got both lines on the same place. So in this case, the second line has got 70 options available. And similarly for this side, we've got 51 options for the first option times 50 for the second option. But the next thing to just take note is it doesn't matter whether we did, whether the order of these lines doesn't matter. So it defines the same rectangle whether this is the first line and that's the second line, or whether this is the first line and that's the second line. So we need to divide this by 2. 70 times 71 over 2, 50 times 51 over 2, following the same logic. And I'm not going to do this, this was obviously just an example, but if we actually do this, multiply it out, we've got 71 times 70 over 2 times 51 times 50 over 2. And if you actually do that multiplication, that would be the number of rectangles that you would be able to get in a huge grid like this. If we apply this logic back to our original example, so we've got, okay, so here there are 4 options for the first line. So it's 4, whichever line we pick, there's 3 other lines remaining, so it's 4 times 3, and the order doesn't matter between those first 2 lines, so it's 4 times 3 over 2, times, same thing here, there are 4 horizontal lines, and then 3 for the second choice, and we need to divide by 2 since the order of the lines doesn't matter. And finally, if we do that, what have we got? 4 over, let's just cancel those out. So we're cancelling out a 4 and 2 2's. 4 times 3 times 3 equals 9 times 4 is 36, which is obviously the same answer. Okay, let's go to question 9. Find the sum of the roots of the polynomial x cubed minus 6x cubed squared plus 11x minus 6. Okay, let's write down that polynomial. X cubed minus 6x plus 11 minus 6. Okay, so any polynomial like this can be broken up, okay, into, it can be factorized. Let's put it that way. So in this case, we know it's going to be x minus a, x minus b, x minus c. And so therefore, and in this case, the roots are going to be a, b, and c. If we actually multiply this out, we're going to get x cubed, and then minus, so that was an x squared, 11x minus 6. Sorry, I wrote down the question wrong. Okay, if we multiply this out, if we take all of the x's, we get an x cubed. If we are going to take 2 of the x's, then obviously we've got x squared, and we will have a plus b plus c. And we actually don't need to go further, but we can. So obviously I'm taking, if I take the first x, and then the b and the c, sorry, I'm taking 2 x's, so I take this x, and that c. Then I can take this x, that x, and the b, and I can take these 2 x's and the a. We can do a similar thing. What we want to do is we want to take 1x, so let's say plus x, and so here we're going to take, let's say we take this first x, we're going to get b times c. So let's actually write this down, b plus. If we take this x, we're going to get ac plus, finally if we take the last x, we're going to get ab. And finally, if we take none of the x's, we get a, b, it's a times b times c. Obviously there's 3 negatives, so we've got minus a, b, c. So from the generic case, that is what we get, but they want to know the sum of the roots, which as it turns out is just this term. That's the coefficient of x squared. So from there, if we go back to the original polynomial, the sum of the roots is 6, and that is our answer, is B. This can be factorized completely just incidentally. If we actually find the factors, we can say A equals 1, B equals 2, and C equals 3. If we check it out, we can see that it works. If we actually substitute it in here, it does work. Here, the sum adds up to, sums up to 6, which is what we wanted. The product, 1 times 2 times 3, does sum to 6 there as well. And if we take this in pairs, B times C is 6, A times C is 3, so that's 9, and A times B is 2, is 11. So those are the 3 coefficients, and those are our roots. But we didn't actually need to do that because immediately we can see that this is it's simply equal to 6. We don't even need to know what the exact roots are. Okay, let's do number 12. This is the last question that we need to solve. Okay, so it says compute, and then there's a sum. I'm just going to write it down. 1 over root 2, it's a plus root 1 plus 1 over root 3 plus root 2 plus 1 over root 4 plus root 3 plus 1 over root 25 plus root 24. Okay, so let's see what we can do here. We want to get or we want to get rid of all of these square roots in the denominator so that we can actually kind of get a common denominator and do all of that stuff. So what I'm going to do is I'm going to multiply top and bottom by basically this again, but invert the sign. So if we look at this first term, I'm going to say 1 times square root 2 minus square root of 1 over square root of 2 plus square root of 1 square root of 2 minus square root of 1. Then I'm going to do that for all of these other terms until I get, well, actually let me do it for a second term just to make it clear. I'm going to do that again here. So this is 1 root 3 plus, not plus, root 3 minus root 2 over root 3 plus root 2 root 3 minus root 2. And finally plus 1 over root 25 minus root 24. And we've got root 25 plus root 24 root 25 minus root 24. And running out of space a bit there. Okay, so this is what happens if you factorize difference of squares. You get one with a plus, one with a minus. So we can say immediately that this is, well, it's going to be root 2 squared plus root 1 squared. So we've got 2 minus 1 over root 2 minus root 1 plus, same here, for the second term we're going to have root 3 minus root 2, and we're going to have that over, we're going to have 3 minus 2, and then we're going to say plus, we're going to have all of these terms in the middle, and eventually we're going to have root 25 minus root 24 over 25 minus 24. I just want to make sure that this is clear. Essentially 25, well, let's actually do it like this. What we've got is a squared plus b squared a squared minus b squared is equal to a plus b, a minus b. Okay, and let us just substitute. For instance, if we say c is equal to well, let's say a equals square root of c and b equals square root of d. What we're going to get here is a squared is the square root of c squared minus the square root of d squared equals, so a is the square root of c plus b is the square root of d, and again square root of c minus square root of d, and simply square root of c squared, if we just, I'm just going to write it on this side, that equals to c minus d. So c minus d is equal to that, and that's pretty much exactly what I've done here. Okay, and now if we simplify that, I'm going to get root 2 minus root 1 over 1 plus root 3 minus root 2 over 1 plus, eventually plus root 25 minus root 24 over 1. And you can see that that square root is going to cancel. There's a plus, here's a minus, it's going to cancel. Similarly, this is going to cancel with the 1 over there, and everything's going to cancel. This 24 is going to cancel with that one, and eventually what we've got is this. I'm just going to write it down. Eventually everything just simplifies to the square root of 25 minus the square root of 1, which equals to 5 minus 1, which equals 4. And 4, question 12, 4 is A. And there we go. That's the solution to the grade 10, 11 and 12 paper. Thank you.